Welcome to Pyrobotics. I'm Adam Gray, and today we're building Fling. Every year, VEX Robotics provides some instructions to build the year's HeroBot, a robot that is purposely designed to be able to play this year's game. And this year, we're playing Pitching In. This robot is not necessarily designed to be the best robot out there or to win the world championships, but it is a fantastic place to get your kids started thinking about what it is that they need to do, what they need to build, what they need to design in order to play this game. In order to find the build instructions for Fling, you want to go to vexrobotics.com and come up here to Downloads, Build Instructions. You're going to click on VEX IQ and Fling, the build instructions here at the link at the bottom. You can see since 2017 in Ringmaster, VEX Robotics has given us instructions for a HeroBot that the kids can start the game with. In Ringmaster we had Stretch, next level we had Flex, in Squared Away we had Clutch, last year's game Rise Above we had Rise, and this year is Fling. One thing all of these robots have in common is that they're not perfect robots. They have some flaws, they have some things that need to be improved, they have some things that will jump out at your students right away. One thing, however, that Fling has that none of these other robots have really had is a certain level of difficulty and complexity in its build. Fling is easily the most complicated HeroBot build that we've been given so far, but it is a fun and rewarding process if you can get past some of the difficulties in the build. We'll be going through a lot of those difficulties today. I really hope you join me in this build. Pause it if you need to catch up, or if you need to find a specific part, but this video specifically is so that we can build Fling together and have a working robot that your kids can be proud of. And by the end of this video, you'll have a working robot that can play this game and gives us a great starting point for what we can make better in our next robot. So let's get started. Okay, so here we have Fling's build instructions. The front cover gives you a picture of what this robot will look like when you're finished. The first couple of pages give you some information about how to size pieces appropriately, how to look for pieces that you need and what orientation they should be in, how to count holes on your parts, how to get pieces apart if you need to disconnect things, and overall generally just some practical tips on how to build what you're looking for and how to tell pieces apart. The next section lists all of the parts that are going to be used in this build. One thing that we're going to do for my summer camp, in fact, is to have only the parts used in the build in the kit so that it streamlines a little bit of the searching process so kids aren't digging through a bunch of parts trying to find exactly the connector that they need. Okay, here we are on step one. The first thing you'll notice on the instruction manual is up at the top, it lists all of the parts that you're going to need for this page. So we're going to be getting started by getting all of the parts that we need for the page, and then we'll build all the steps in the parts, and then we'll move on to the next page. Once we get to the next page, we'll repeat that process. Now, there are some parts in this build where I may deviate a little bit from the instructions, and I'll explain a little bit why when we get there. There are not very many deviations. If you are building this from an older version of these instructions, please note that there are some mistakes in the very first version of the build instructions. Caution Tape has been so kind as to put out a visual guide for corrections that I'll put in the description below. However, we've gone through these build instructions a couple of times since then, and they've made some of the changes, the modifications that are needed. There's still a couple of minor discrepancies here and there, so I'll call them out when we get to them. Otherwise, you can pretty much follow this straight beginning to end and have a successful time building this robot. There are definitely a couple of tips and tricks that'll help you build this robot more efficiently, and I'll call those out when we get to them too. Without further ado, let's dive in. Okay, so the first piece we need up at the top left up there is we need two 3-pitch capped plastic shafts. So the X2 at the top is the number of parts we need, and the 3X is the pitch number. So now, pitch, a lot of people think about pitch as being the number of holes. And while the number of holes do kind of line up with the pitch, technically the pitch is the distance between the grooves on your plates and your beams. So everything that we need to measure pitches with, we'll measure them against a plate or a beam so that we can make sure we have the right part. Okay, so we're looking for 3-pitch capped plastic shafts. Okay, and I think I have one right here. So we will put that up and measure it, and that is 1, 2, 3 pitch. So this is the correct one. So we need 2 of these. So we'll pull out another one of those. Okay, so we've got those 2. Put those kind of up close to where they're supposed to be. Okay, we also need 1 2-pitch motor shaft. And you can tell the motor shaft apart from the other shafts because it has a ridge instead of a cap. Okay, and the purpose for that is so that it can be seated inside of a plate and still have some sticking out for a motor to grab and turn. And that's exactly what we'll be using it for here in a minute. So the pitch measurement for the motor shaft actually goes from the ridge to the end. So if we need a 2-pitch motor shaft, we have 1 2-pitch there. All right, so we've got that part. So we need 3 36-tooth gears. So these are the 36-tooth gears. If you don't know about the teeth measurements, written on these on one side, there is a, let's see if we can get that up close enough to the camera. There's a 36T written there. So that's the number of teeth. The only one that doesn't have a number of teeth written on it is the 12-tooth gear, and that's the smallest one. And it is also the least number of teeth that you'll ever be asked to find. So we won't have to deal with the 12-tooth gear for a while yet, but for now, we've got our 36-tooth gears. So we also need 2 2x12s. So those are 16s. I believe these are 12s. So there's a number of ways to do this. You can just count the holes, but what I tend to do is I figure out where a half point is, like halfway, and then I look at groups. So I've got 3 and 3, so half of this is 6, therefore it's a 2x12. So we need 2 2x12s. We need 1 1x3. So 1 1x3 beam. We need 1 1x4. And we need 2 2x2 connector pins. And we need 2 1x2 connector pins. Okay, so now that we have our parts, we can start on our steps. And of course, I put the parts right in front of the steps, so we'll move them down and get them out of the way for now, off to the side, into our build area. Okay, so step 1. We start with a 2x12 and we put in our shafts. So looking at the picture, you can see that, let's see if we can find exactly where to point to this. So looking at the picture, you can see that the motor shaft goes in the middle, right? And the 2 cap shafts go equidistant from the ends. So the way to count this, the middle hole is the middle hole. So that one at least is fairly obvious, right? So the way that you count this, though, they're on the 3rd hole in the middle, though. But so the way that they want you to count it is 3.5. So we'll go 1, 2, 3.5. So the first one goes there, and the other one comes from the other side. So 1, 2, 3.5. So for the record, we're not going to be going this slow the whole time. I just want to start out so that we establish a baseline. So you know exactly what I'm going to be doing as we go through this. For subsequent steps, I'm going to be pulling parts out a little bit faster. And anytime that there's any sort of counting of holes or making sure that parts are in the right place, I'll be sure to call that out. But for the most part, we're going to kind of sort of speed through this. Pause it if you need to, if you're building along with me. I encourage you to rewind as necessary and leave a comment if there's something that I could have gone over better. All right, so we've got our shafts in here. So they also want us to, now in step 2, we put the 1x3 and the 1x4s on. So in the 1x3, they have us putting these 1x2 connector pins in the top holes on the 2 side all the way through. So the top 2 holes there, like that. Okay, and that is gonna go on this side there. Like that. So we'll leave that there. And then the 1x4 is going to get the 2x2 connector pins, and those go from the back in the bottom 2 holes all the way through Okay, and then it's going to go all the way through the other direction. This one is going to be facing up. Let's make sure our shafts don't fall through the wrong way. All right. So once you have this, you should have your 1x3 with the 2 pins, nothing on the back. That is flush. And then your 1x4 has the 2 pins on this side and 2 pins sticking out on this side. Okay, so we'll move on to step 3, and that has us putting our 36-tooth gears in. I like to do the middle one first. I'm not really sure why. It's just a personal preference. So we get those on there. And for step 4, they want us to put this on it to keep everything all nice and captive. So now we're left with what looks like is going to be, and in fact is, the beginnings of the side of a drive base. So we'll set that aside, and we'll scroll down a little bit on our instructions and move down to step 5. So step 5 is one of those places where I feel that there could be some improvements made. What ends up happening, if you look ahead in the instructions, is that they have you put these washers on, but they never have you put the wheels on. So what ends up happening is you're moving your parts around and the washers keep falling off all the time. So my recommendation is understand that there needs to be some washers or spacers. I actually prefer spacers, but that's up for you to decide. They go on before the wheels. We're not getting to the wheels yet, so we're just going to skip step 5 for now. It's just not necessary. So we're not going to get the 2 washers. We will get the 4 1x1 connector pins. Okay, so we've got those. We need 4 large chassis corner connectors. That are these. They look like that. And we need a motor. So we've got our motor. Okay, so since we're skipping step 5, we don't have to put our washers on for the wheels. So notice you're going to have to be careful which side of this you're looking at, because one side has the motor shaft sticking out and one side has all 3 shafts sticking out. So the wheels are going to go on this side eventually. It's not relevant right now, but just be sure that you're looking at things from the right direction. So if you can see in step 6, it's got the orange arrow. It wants you to turn this around so that we're working on the other side. Okay. So we're going to take these large chassis corner connectors and we're going to make sure that it's in exactly the right orientation. So where it wants this to be is on the holes just to the right of the first cap shaft. And it wants the flat side of this large chassis corner connector to be to the left and the other connector pins down. So if you can see that there, it kind of looks like that. And that's hopefully that angle more or less matches what you're looking at in the instructions. Okay, so the other side, it has it actually going the other direction where they go up. This has it not going on the holes directly adjacent to the capped shaft. They're one over. So we're going to put those here. Okay. So we'll move on to step 7, and that's putting these last 2 in. So you can see in step 7 that it still wants the flat side on the outside, but with the connectors on the top this time. So flat on the left side. And this time the flat side is going to be on the inside with the connectors pointing down. And that is going to hold that shaft captive. So now those don't push through, you see. Okay, so that looks like that. And then in step 8, we're going to be putting connector pins into the motor. And then we'll be attaching the motor to the drive. So what you want to try and do as you put motors into this is try and match up the square shaft with the orientation of this motor. So this one has the shaft hole as more of a diamond. So we're going to move our shaft into more of a diamond position, and that should make it a little bit easier to snap it in. So once you get that in there, give the gears a turn, and you can hear the motor engaging, so you know you're done. So that is really starting to look like part of a drivetrain. Okay, so now we will move on to step 9. Okay, so looks like here again we're going to start working on the other side of the drivetrain, which is in fact exactly what we're going to do. We're going to need 2 more of those 3-pitch capped plastic shafts. So we'll pull those out. There's one. Double check that that is a 3-pitch. 1, 2, 3. Looks good. So there's 2. And we're going to need, since my hand's already in there, we'll grab the motor shaft that we need. So the 2-pitch motor shaft, we'll get to that. We need 2 more 2x12s. So we've got those. We need 2 more 1x1 connector pins, 4 more large chassis corner connectors, and we're good to go. Okay, so this part is pretty straightforward again. So we got our motor shaft in the middle, and then our capped shafts at 3.5 from each end. Okay. So now these corner connectors are slightly different, so make sure you pay attention. Notice we're holding it the wrong direction right now. It wants us to be holding it this direction. So be careful that you're holding it in the right direction. So the flat side is going to go on the inside this time. And this is going to go directly to the left of the capped plastic shaft with the connector pins down here. The next corner connector is going to do this exact same thing in the exact same orientation on the next connector pin. Okay, so we've got those right where they need to be. The next corner connector is going to go with the flat side towards the left and the connectors towards the top. And the other one is going to have the flat side towards the right and the connectors towards the top. Okay, so we're good there. Now we have 2 connector pins that go in the second holes on the end here. And we're done with step 12. So I guess I only needed the 1 2x12, but we know we're going to need the other 2x12 here pretty soon, so we'll just hang on to it for now. All right, let's move on down. So for this next part, we need a 1 2x4. Slide this down out of the way for now. So we've got our 1 2x4. We need 4 1x1 connector pins. We need 3 more 36 tooth gears. 2 2x2 connector pins, a motor, and 1 2x3 right angle beam, which I guess I'll put it down here so you can see it. All right, that has our parts for all the steps. So we're gonna start step number 13. So the first thing they want us to do is to put these connector pins in the motor, just like last time. And we're going to get that in there connected. So again, I've got the hole that it's kind of in the diamond shape position, rotated 45 degrees. So we're going to try and make sure that this gets rotated 45 degrees as well. And there it is. Okay, so we're good. If you can turn this and check the motor is connected, feel free. If not, then in the next step, we're putting on these gears. So again, I like to start in the middle. There's one. And the nice thing is we've got everything, these being held captive, so you can push on them a little bit now. You don't have to worry about them going crazy. Okay, so there's step 14. We've got our, let's try and turn it so that you can see it kind of like the picture. So that looks pretty good. Okay, so we've got our right angle beam, which is going to go on like that. And it has the 2x2 connector pieces going through the top 2 holes on the long side, on the 3 side. And that goes in right there, all the way through, so that you have connectors pointing out here and on the other side. Notice on this side there's 4. Guess what that 4 is for? It's for the 2x4. There's step 16. Look at that. we got two sides of a drivetrain. And we're gonna start to add a little bit more to this particular side on the drivetrain. So we're going to need a 4-pitch motor shaft. Make sure that we get the right one here, because there's a couple of different ones. So again, we're measuring from the ridge. So 1, 2, 3, 4. So this is our 4-pitch motor shaft. Move this down kind of out of the way. So there's our parts. And we're going to need the smallest pulley. So if at any point you ever get a little bit confused about what something is, what it's called, where to find it, if this is the right part or not, in your super kit, it came with a parts poster. If you don't have the parts poster on hand, or you got rid of them or lost them or whatever, you can still go to VEX's knowledge base to pull up a parts poster. So on this parts poster, it has all of the hole numbering for beams and how they operate. It has examples of how you would measure the pitch. So the other thing that it has is that it has sizes of things. So we've got cables, so the 200, the 300, the 400, the 600 millimeter cables. It's got our smart motors that has all of the sensors and everything. So this first thing that we ran into here is this pulley. So the smallest pulley, I couldn't remember exactly what the size was. So here we are on the parts poster, and it is in fact the 10 millimeter pulley. So just know, if you ever have any questions about what a part is called or where to find it or what it looks like, pull up the parts poster. It has everything on there that you would need for the most part. I would also add that during interviews, it's really impressive to judges when your kids know what the parts are called and what their uses are for and why they chose specific parts over other parts. So one of the things you could do in your practices is have parts quizzes. It's a great little warm-up activity. You can do it in like 30 seconds or so. Just have like 5 random pieces that they have to go find, make a race out of it, make it fun, but teach them the names of the parts. In fact, learn the names of the parts yourself. That's so much easier when we're talking to kids about how to build a certain mechanism or trying to come up with a part that might be able to fit in a certain spot. It's a lot easier to say, well, I need the 2-wide 2x1 corner connector, rather than just, well, you know that black thingamajig that has the 2 pins and the holes and like this, and it's a mess. There's so many corner connectors. Highly recommend, learn the names. They will help you a ton and gives your kids the confidence that they need to talk to the judges and other adults when they're asked questions about their robot and how they built it. So now that we've learned that this is a 10 millimeter pulley, we have our 10 millimeter pulley. So we need 2 spacers. So we need 2 1-pitch standoffs. Okay, got those. We need 2 1x1 connector pins. We need 2 1x2 connector pins. 1 1x3 beam. 1 1x4 beam. Got those. 1 1x6 beam. We have that. And the other 2x12 that I got out super early. Now we actually need it. Okay, so step 17. So we're starting with the 1x4 and the 2 1x1 connector pins out here. And those are going to go on the outside of this, like so. Okay, step 18, we have the 2 1x2 connector pins. Those are going to go in the 1x3 in the top 2 holes with the 2 side going all the way through, the 1 side going into the 2x12 here on the end. Okay, so it's going to look like that. Okay, step 19, we're ready to put this 2x12 on to hold everything together. Snap that in and we're good. So that looks like that now. Okay, and now the 1x6 gets both of these standoffs. one hole on the inside. And our motor shaft. This is a part that can be difficult depending on how tight your pulleys are and how much you've used the plastic shafts. So I recommend just pushing it against a flat surface like that to get that on all the way. And then 2 spacers are going to go on there. Okay, and that's gonna rest right there. But for now, like, that's not super steady and stable, so we're just gonna set that down for the moment and move on to step 21. So for this one, we need one 4x45 degree beam. So when you're looking for these angle beams, there are 3 different sizes, and they go like this. I only have the parts out that we're actually going to use in this build, so I only have the 30 and the 45. There's also a 60 degree angle, and that is even more straight up, more of a right angle. Okay, so there are also several different right angle beams that we aren't going to be using in this either, but this is how you tell them apart. So the 30 is the one that looks like it's almost laying down. The 45 is the one that's going to be in the middle if you get 3 of them out. Like, it almost looks like it could be, you know, a 30 or even a 60, depending on where you're measuring the angle from, but it's a 45. It's not very steep. It looks like it makes kind of a nice, like, laid back chair. The 60 is the sharp one, but for now, we're just going to use the 45. We'll put this 30 back for now. So we got our 45. We need another 1x6 and a 1x12. So, easy way to tell the 1x12 when you have a 1x6. So that's not a 12, is it? That looks like 10. Your 1x12 should be twice as long as your 1x6. That's math. So 2 1x1 connector pins, 3 spacers, 2, 3, 2 2-pitch standoffs. If you have all your standoffs in one container, sometimes the smaller ones can get to the bottom. So what I've done in the past is I've separated out the 1 and 2 pitch standoffs from all of the other ones, because otherwise you end up digging underneath all of the longer, the 4 and the 6 pitch standoffs. But we're using the 2 pitch there, and we need, oh, here it comes. So we just talked about this, but this is the 2 wide. So because it has 2 connector pins, it's 2 wide. Right? So height is first. So 2 by 1 corner connector. Good? So we'll come over here to the parts poster. There it is. So you can see it up there in the top right. 2 wide, 2 by 1 corner connector. So the one above it is offset. And we'll come back here so you can see it again. So you see how the offset one is further away from the base. So we'll come back here and you look, and we've got our holes really close to the base. So this is a 2 wide, 2 by 1 corner connector, not offset. Okay, so we've got that. And we're ready for step 21. So step 21, we'll hold this captive. So this is also a really handy trick to know, is that sometimes you can use these 1x beams and the standoffs to hold things together. We're going to see something that's a lot like that with the gears, where we use standoffs and 1x's to hold the gears into the plates on the side. That's a really clever use of the 1x's. I've had kids use them in the past for holding gears onto plates as well, especially idler gears, which are kind of in the middle. So one of the things that does is it prevents you from having to use so many shaft collars all over the place, and it can really help out with friction sometimes. If you were doing this as a real build, I would recommend putting a washer in between this pulley and the 1x, but it's fine. This isn't a really high revolution part. It's not going to be that big of a deal. Okay, so step 22, we're going to take our 1x6 and put our standoffs, one in the end, and then one in the third hole. And and this is going to go off to the left. Okay, so that should look like the picture. Okay, so now we've got on this side, our 1x1 connector pins are going to go in there. And then our 2x1, our 2-wide 2x1 corner connector goes right there. So you can see that matches the picture. So we're good there. Anytime you see a box in the instructions, always do the box first. Okay, so now we're on 23. So this part is going to go in right in the middle of the 2x12, just like so. And our last 3 spacers, if I don't throw them around, go on that particular shaft. Okay, we'll set that aside for the moment. Okay, moving down to 25. This is where things get fun. So we need a shaft collar. Got a shaft collar. We're going to need a bunch of the longer standoffs. All right, so this wants us to have 4 6-pitch standoffs. And if you saw at the parts poster, you measure the fat part of the standoff. 1, 2, 3, 4, 5, 6. So these are 6-pitch standoffs. So we got our 4 of those. Okay, and then here is our 40mm pulley. I think I got that right. Double check me. Okay, we need one of those. We need 4 1x1 connector pins. We got 3. And we need 4 4-pitch standoffs. So we'll measure again. 1, 2, 3, 4. Good. So we have our 4-pitch standoffs. And I almost skipped a part. So a lot of people don't use these, but these are standoff connectors. So what we're going to be using them for is exactly their intended purpose, is for connecting standoffs together. One of the things that we've used them in the past, though, is using them as a spacer, because instead of using like 3,000 of these little guys, we can just use a few of these, and then you can get different colors and make fun little patterns too. But we're going to need 4 of these. All right, so we got our 4 of those. Okay, so step 25, always start in the box. So we got our 40mm pulley, and we're going to put our connector pins in. These connector pins are eventually going to hold rubber bands, but we don't know that yet. And those are going to go on the inside, I guess technically facing towards the outside, but that's going to go on this shaft, and then our shaft collar is going to hold that in. Okay, so that's good. Now we have these. So you see in the box, it wants you to connect these, the long one to the short one, with these connector pieces, and you want to do it 4 times. So we'll just do all 4 of the long ones, and to those we'll connect all 4 of the short ones. And we're going to turn 2 of them the other way around, because if you look in step 26, it actually has them kind of staggered like that. There's not really a particular reason for that, so don't feel like you have to, but it looks better, so why not? So these go into the remaining holes in the 40mm pulley. So we're going to alternate on the way around. So long one, short one, long one, short one. And we're good. So shortly we'll be coming up to the next section where you have to connect the other side, and that part can be a little bit tricky. Okay, so moving on to step 27. I'm gonna just move some of this stuff out of the way. Get some more screen real estate here. Oh, I was using this for measuring. Okay, just put this up there. Okay, so we need a 3-pitch capped plastic shaft. And we'll measure again. That is 3-pitch. Okay, we need the other 40 millimeter pulley. We need another 1x6. 6 1x1 connector pins. Couldn't do that again if I tried. The other 45-degree angle beam. 2 2-pitch standoffs. 2 2-pitch standoffs. And one more 2-wide 2x1 corner connector. There we go. Okay, so we're going to start by putting the capped plastic shaft through the pulley. And we're going to attach that pulley to all 4 of those at the same time. So what I like to do on this, in this particular case, you got to notice that it goes in the square holes in the middle, not the ones on the outside. So I like to do kind of 2 at a time. So if you start with one side, then you can kind of sort of push them in, but not all the way. So you have a little bit of space left over to align the other 2, and then you can pop it in the rest of the way. So otherwise you end up pulling these apart and things are moving around all over the place, and you might get a little bit frustrated. Your kids might get a little frustrated, but just do 2 at a time. One side, do it kind of halfway, and then pop it in the rest of the way. It should be good. All right, so then we got our 4 connector pins go on the outside of this guy. And that matches up with the other side here, which is good. Okay, now number 29, we're going to do something similar to what we did before, but this time it's going to be facing towards us. So we've got on the end, skip a hole right there. And then the angle is going to come towards us off to the right. Okay, 2 more connector pins on the end here. Did I grab one too many connector pins? I must have. 4, 5, 6. Yep, I sure did. All right, we'll put that back so we don't lose it. And our 2-wide 2x1 corner connector goes in there. Okay, moving on to step 30. Going to need 5 spacers. See, this is one of those cases where using one of those there's 5. So this is one of those cases where using a standoff connector instead of 5 spacers might be worthwhile, as long as you can get the lengths to match up correctly. Sometimes you have to add a washer in there just to get it perfect, but it should be fine. We've got a lot of spacers. We'll just go with it. So we also need a 1x12. 5 spacers and a 1x12. So 1x12 connects in exactly the same spot as it did on the other one, right in the middle. So, ta-da. Okay, our 5 spacers go directly on the end of this axle. Shaft. Okay, and that is going to go there. So you get this on there and it just looks mirrored from the other side. This isn't how it's on there, so we'll flip it over, and that's kind of, if I hold it like this, you can kind of see it. It looks like the picture now. Good? Good. Okay, so we'll move on to step 33. So we need 1 more spacer, shaft collar, 1 more 1x1 connector pin, and a rubber band. Okay, so here's our rubber band or elastic band. So step 33, our connector pin goes here on the end, spacer goes here, and our shaft collar goes here. So did you see what happened just then? Move my hand. You see that right there? So I tried to put the shaft collar in and it pushed the shaft in. So this is something that can definitely happen with your kids. So what I do is I just put 1x in there, see, to hold the shaft. And then you just push this against that piece, because there's not a whole lot of room left over for this. So that way you can get it nice and tight and you're not pushing it through, you're not fighting with it. So sometimes you just got to use the parts as tools. Okay, and a rubber band will go on one of these connector pins, stretch across to another connector pin. So it's going to look kind of like that. Okay, the next several steps are just doing 3 more of those. So you can trust me on that, and then we'll up until this part where suddenly in step 38 you're bringing back a part that we built before. But for now we're just going to make sure that we get these rubber bands all on there. So what we've just built here is the intake mechanism. It utilizes this cylinder with the rubber bands to grab a hold of the balls and pull them into, well, in this case it'll be a catapult, but a lot of times it'll be some type of reservoir. If you have a sprocket, chain and sprockets kit, or a tank tread kit, sprockets work really well for these. So you can use the teeth and then put a rubber band like all the way around in the middle of teeth, and then you don't have to use connector pins with the pulleys. But if you don't have those, the pulleys work pretty great as a substitute. Okay, so we got those, and then we'll bring back our drivetrain parts. So this has us with this one. You can see it matches the picture because it's got the 2x4 in there with the 1x4 and the 90-degree angle beam. So that's going to connect right there. Okay, so it's on the outside. So what this is going to give us is the ability for this to rotate up and down. And this 1x4 will be a stopper, so it has a little ledge to stop on. So this will be handy when you're kind of up close to walls. Okay, so that's step 38. Go on to 39. So we need a 3-pitch motor shaft, plastic motor shaft. And again, we'll measure just to be safe, and it measures from there. So 1, 2, 3. Okay, so we've got our 3-pitch motor shaft. If you haven't bought the metal cap shafts and motor shafts, I highly recommend them. As we get closer to the end of the build, you'll see that these flex a lot, but the metal ones are just fantastic. I know my teams utilize them all the time. I probably need to buy more. Okay, aside from that, we need 7. Actually, read that right. 7. 1, 2, 3, 4, 5, 6, 7. 7 1x1 connector pins. We need a 4x4 plate, a 2x4 plate, and a 1x6 beam. Okay. So our motor shaft is going to go in the end over here. Okay. So this is one where you got to start to kind of be a little bit careful. Okay. So 2 connector pins go on essentially what is the back side of the 2x4 plate. And then while you're holding this with these on the back side, okay, we're going to put connector pins in here above the 2 that are going the other direction, and then in the middle, here and here. So this is something that I've seen trip people up a little bit. Make sure that you've got 3 coming out this way and then 2 coming out that way. Okay. And then these are going to connect. This connector pin is going to go in the top corner of the plate. So those 3 go through the plate. The other 2 on the other side are still out. Okay. So we're good here. Now we have our 1x6 and the connector pins go on the bottom and then skip a hole. So on the 3 hole. And then those are going to go not on the side in the corner, they're going to go on the middle. So these middle holes. Okay, so we're putting that in there. See how those are in the middle. Okay, don't get confused by that one. That one's a little tricky if you're not paying close attention. All right, step 42. 2 more 1x1 connector pins. So this is now going to go in there. I don't know if that was easy to see, but it is in this corner of the 2x4. Okay, and that's all there is to step 42. 43 is putting the 2 connector pins starting at the top here and here. Okay, see those? So we're good. Okay, now we need a motor and another 10mm pulley. So we got our pulley and a motor. Okay, so the motor is going to attach to the motor shaft, and it's going to connect to these connector pins. Now notice there's not a whole lot of connector pins to connect this to, so it only connects with these 2 middle holes here. So, and again, we're noting that mine is kind of 90 degrees, so we're keeping our shaft kind of 90 degrees. Line up. Snap that on there. Give it a test to make sure we're in the motor correctly, and we're good. Okay, and our final 10mm pulley. So we've turned this around. And in this case, it means basically flip it over, but okay, so we've got this flipped over. So it's going to go here, right, onto the other side of the shaft that we just put through the motor. So this pulley will sort of kind of line up with this side now. So it actually does. So now you can see, like if I rotate this, this is a good hint that the width of a plate is basically the same as 2 spacers. Okay, so we've got our intake built. So now we're getting our largest belt. Now, the kit that I had didn't have any belts left. They either all broke or we lost them. So what you can do in the meantime, and I think the original instructions had you do this, is to use a rubber band instead. Now, I've had mixed results with using a rubber band for this. There are times where it can work its way off of the pulley and then it gets wound up and wrapped up and then it can break. So be careful if you're using a rubber band. Use the 60mm belt if you can, the elastic belt. Otherwise, if you've got a chain and sprocket kit, there are some modifications you can make to this to make it use a chain, and it's way more effective and a lot less error prone. But for now, we'll just use a rubber band. So that's going to go around the pulley on the motor. I'm going to take it to the other side of the pulley over here, and we're more or less good there. So this will work. I've had a couple of versions of Fling using the rubber band and it works just fine. So your mileage may vary. And that's all there is to step 46. So 47 is to add our other drivetrain on. We still have this upside down like this, so this one needs to be with the 1x4 facing down. So that looks good. And that is going to connect on the end. So what's going to happen here, and one of the reasons why we couldn't put more connector pins in the motor is because these connector pins are going to go in these 2 open holes. So there are ways we could have done that a little bit differently, but this is just fine. So that's going to go in there, but it connects with that. Okay, so now we've got our drivetrain. So if we flip this over, you can kind of see it starting to come together. So we got our drivetrain, we got our intake that kind of flips up and down a bit. Okay. And we can move on to step 48. So moving on, 6 2-pitch standoffs. Six of them, and 2 2x16s. All right, put that there. So on the first 2x16, goes in the 3rd hole and the 3rd hole here, and then those two and those two are going to go in the large chassis corner connectors. So we have to make sure that we've got this facing the right direction here. So notice on the instructions that the 1x6s are on top for these particular pieces. So we need to flip ours over. Okay, so with the 1x6s on top, our picture looks the same as that one does now. So now this will go in, and these two will connect to this large chassis corner connector. And these will connect to the other side of the drivetrain. Okay. And then our other 2x16 gets 4 of these guys. So this time they're going to be on the outside here, so we're going to put them on the inside here. That's going to go in the 3rd hole and the 3rd hole. And we're going to skip 3. That's going to go there, skip 3, and that's going to go there. We got 2 holes in between in the middle. So we've skipped 3 between the 2 on the outside. So now when we flip it over, it looks like what they expect it to be. So these are going to go on the outside of this back 2 large chassis corner connectors. And one is going to go here. And this one is going to go there. So now our drivetrain is kind of connected. So we'll come down here to step 50. We're still in this orientation. We need 2 more 1x1 connector pins. And put those over here. We need one wide offset corner connector. You can tell it's offset because there's a space before the hole. And it's 1 wide because it only has the 1 connector pin. Okay, and we need a 1x8. So we got our 1x8. Okay, so we have 1 connector pin goes in this 1 wide, and this is going to connect here in the 2nd hole on the 4x4. You can see that right there. Okay. And then the 1x6, one side is going to get the connector pin, but the other side is going to go into the corner connector that we just added. And the other one, so if you just rotate it around, you'll find the hole that it goes in right there. So we got a little cross support for our outside of our intake. Okay. Step 52, we need 1 small chassis corner connector. That's what these look like. Another 1 wide offset corner connector. Okay, a 2x8. 2x8. So we need 3 1x2 corner connectors. So 1 high, 2 wide. So these are 2 wide 1x2 corner connectors and 7 1x1 connector pins. There's 2, 4, 6, 7. Okay, so we're building something new here, so we can move this off to the side for now. Got a little bit more space. All right, so we got connector pins that are going to go in the bottom 2 on both sides. And a 2 wide 1x2 corner connector is going to attach to that. Same thing on this side. Have another one of those. And we needed 2 2x8s. Why didn't you tell me? Embarrassing. All right, so we built that, and the small chassis corner connector. Be careful that this is in the orientation that they're asking for. So that means the flat side is on the outside, okay, with the connector facing away from the 1x2 connector. Okay, that's 53. So 54, we're going to take our other 1x1 offset corner connector, put a connector pin in that. That's going to go on the outside of our 2x8 here. Okay, so this is the same 2x8 that we've been building on. 55 starts a new one. So now we have 2 more in here. We get our 1x2, 2 wide 1x2 corner connector there. Okay. And we should have saw this coming. We're going to be building some more of those. So we're going to need 1 more 2 wide 1x2 corner connector. We need 7 more connector pins. There's 6 and 7. Throw it across. Okay, and we need a 4x12 plate. Looks like that. Okay, continuing on. Got our 2 connector pins here with our 1x2 connector there. And 57. Skip the small chassis corner connector, which then will go with the flat side facing inside this time, not the outside, so like that. Okay. And then flip that over. And our 1 wide offset corner connector is going to go there with another connector pin in it. Set that aside, and then our plate is going to get 4 connector pins on the short end and move on. So for here we need a 2x4, 1 30-degree angle beam, 1 metal. You can tell because it's silver. 4 pitch metal shaft. Okay, so that should be that. No, it's definitely not that one. This one. 4 pitch. Matches the 4x4. And 6 1x1 connector pins. So we got our 6 there. So step 60, we got our 2x4 plate. We get 3 connector pins go in the middle of the plate, and that is going to connect. So not to this side where these are sticking out, but flip it over so that it's flat, and then this goes on the top of that plate. So the 2x4 on the top, these are on the bottom, facing the other direction. Okay. And then 61. So we're going to come down so you can see where the 4x4 is. So it's not going to be in that hole, but this one right here. So from this other side, putting that in there. Okay? So it sticks out on this side. So then we're left with, in the top of this 2x4, 2 connector pins there, and then our 30-degree angle beam goes on like that. Okay. And then our metal shaft, you count up, so we're at the 1 hole. So then the 2, 3, 4, and a half in the middle. So that will go there. Now you gotta kind of hold it for now, because this is gonna be a little bit before we can actually cap it off. Okay. So for this step, we're going to need 2 washers. So these are the thin ones. Okay. So we got our 2 washers. 2 1x1 connector pins. We need 8 1x2 connector pins. Okay, so here is a small mistake. After the 8 1x2 connector pins, you can see that it says 2 2x4s. Those are clearly not 2x4s, they're 2x2s. But I would also recommend that instead of 2x2s, you use 2x2 lock plates. The lock plates look like this. Generally in your super kit, they're black, but they have a center hole that is a square. So what that does is it spreads out the area that is under stress inside the gears, because it's where these are going to go. They're going to go in the middle of the gears so that your gears don't get stripped out. This is one case where this gearbox is going to be kind of high torque. So one of the things that can happen is your metal shafts end up kind of cranking on your gears and it can strip out the inside. So we don't want that to happen. So we're going to use lock plates instead in this particular case. And we need 4 60 tooth gears. These are the big guys. Okay, so this part, it gets a little bit tricky. So at least 64 is easy. So we just need a couple of washers on there. We'll just stick those on there for now and let that kind of just sit out of the way for the moment. But these, so one thing that you'll find the longer you go on with this is that the gears have sides. So certain gears, if you don't have them lined up properly, the teeth won't line up exactly correctly, and you could maybe get a little bit of a shake in your mechanism, or like if your arm is coming up, like your arm might be a little bit tilted and you could never figure out why. Sometimes it's because you have one gear that you need to flip over because the teeth aren't matching up exactly perfectly. So one way to get around that is just to make sure that they're facing the same way, so that the print, you can see here, so the printing is on the same side facing the same direction, and then you get them to line up so that all the slots are perfectly lined up. That way, you know, since these are most likely injection molded, they're all exactly identical if they're facing the same direction and the same orientation. So we're going to shoot for having them exactly the same orientation, the same facing direction, and we should be good there. So the first thing I want you to do is put these 1x2 connector pins through your 2x2. We get 4 of those. This is also something I highly recommend doing in your wheels, in addition to your gears, just to give it a little more stability. Okay, so we do that twice. Put all these in our lock plates. Okay, and then it wants you to put one side through here. And then again, we want to make sure that everything is lining up exactly right. So we'll put it through exactly the same on both sides. So this one, we'll make sure that they're both facing the same direction. We'll just put the VEX towards me, towards the camera. Get them lined up the same. Okay, so our lock plate's going to go there. And then our gear is going to go there. So we've got our 2 sets of gears. Okay, and they also want us to put 1x1 connector pins. And then one thing you'll notice on this particular part is that it says you want 2 of these, right? But super kits don't come with these. I mean, they come with these, but not the ones that's pictured. So in the picture, it's got with the holes. So what those are called standoff extenders. The super kit doesn't come with those. So if you haven't purchased standoff extenders, you won't have that. But what can work instead of the standoff connectors are these, which are shaft bushings. They look exactly the same, except the hole is square. They're pretty much exactly the same thing, just with a square hole instead of a connector hole. So feel free to use these. They work great. They're exactly the same almost. We're not putting anything inside the connector anyway, so these do exactly what they're supposed to do, exactly the same way. Okay, so we got those built. And here's one of the cases where I told you they do something a little bit clever with standoffs and 1x beams to hold gears in place. So one of these we're going to use, and one of them we're not yet. But we'll get there. Okay, so let's grab all the stuff we need. So we need a 6 length, 6 pitch cap, or a 6 pitch metal shaft. This is an 8. That's too long. So there's the 6. So we need 1 6 pitch metal shaft. We need 4 1x4s. So we got our 4 1x4s. We need 2 1x8s. Okay, so we got our 1x8s. 1 1x12. 1 shaft collar. 1 connector pin. 1 1x1 connector pin. 8 half pitch standoffs. So these are the smallest ones that you have in your kit. There were quarter pitch standoffs in one of the game element kits. I forget which one. 3, 6, 7, 8. So we got 8 of those guys. We need 2 2x2 connector pins and 1 4 pitch standoff. Okay, so first things first, we have our standoffs that go in the 1x4s. So each gear is going to get 2 of these, so we have to build 4 of them. Okay, that's 68, so 69. Now we're starting to actually put these on here. Okay, so we'll hold here. We'll just match up the picture best we can. Okay, so we got our gear in there. That's good. So now we'll use 2 of these. One at the top and one at the bottom. Look at that. So these hold it captive. They kind of go in the middle here. It's fantastic. So one thing they don't do a good job of really pointing out and making sure that you understand in this particular diagram is that it is vitally important that this shaft does not stick out at all. So the way that this mechanism works is that there's going to be a connector pin or a beam attached to this connector pin. And it needs to be able to rotate freely through here until it hits this shaft bushing. Okay, so you need to push this down until it is flush with the motor so that you can get all the way around to that shaft bushing. Because what's going to happen is this gear is going to rotate and the shaft bushing is going to push this 1x beam as part of the linkage. But you don't know that yet because you haven't built it yet. So I'm telling you right now, so take it as a warning, make sure that these shafts are all the way flush with this gear. Okay, it'll save you a lot of headache later. Trust me. Okay, we'll set that aside for the moment. No, I guess we won't. We'll just use it. Okay, we get a connector or a metal shaft going through there. So this is going to go on the outside, 1 shaft collar on the outside, and then our standoff is going to go here. So we're at this point now. That's step 70. Now we can set it aside and go on to 71. So these kind of get set aside for now. So in 71, we have our two 1x8s. So the 1x1 will get connected, not in the end, not in the second one, but in the third hole. And our 2x2 connector pins will be in the last two holes here. Okay, and then just sandwich it together. Okay, so they're a little bit stronger, and then our 1x12 is going to go on the end just like that. Okay. So now we need a 2x3 right angle beam. We need 3 1x1 connector pins. We need an offset right angle beam. That's what that is. A 1x10. So that is a 1x10. We need 2 of those. We need another 30-degree angle beam. 1x6. And 4 2x2 connector pins. 2, 3, 4. Okay, so the piece we just built, we're going to get 2 of these 3 connector pins. We're going to skip 2 holes and put them in the next 2. It's going to be here and here. And our 2x3 right angle beam is going to go there. So try and get it to look like the picture for you. It looks kind of like that. All right, so the 73, we're taking our 1x10s, and we've got our last connector pin goes in the middle, and our other 2x2 goes in either end, that same one. And we do the same thing we did with the other 1x6s, we just sandwich them together. All right, like that. We needed 2 1x6s. There's your second 1x6. Okay, so those are going to go on the end of one of these, like so. Okay, and then this is going to connect just in front of the 2x3 right angle beam, but on the other side of it. So on this side. Okay, we're getting pretty close to having our catapult arm starting to show up. It's now a 30-degree angle beam. We have a 2x2 going through there, and a 2x2 connector pin going through there. And then our offset right angle beam connects there. Okay, and this is the start of the beginning of the claw or spoon or scoop that'll do the catapult. Okay, step 76. We need another 30-degree angle beam, another offset right angle beam, and 2 more 2x2 connector pins. Okay, so again, our 2x2 will go into 30-degree angle beam all the way through, like so. Those are going to, wait. Yeah, just like that. Because that way they match up, so they go through the other 2 on that side. So that's going to connect through. So now you have 4 connector pins here. You've got 2 left on this side. So connect our offset right angle beam there. Okay, and that is going to connect to the end here, just like that. So now we need another 1x12 and 2 1x2 corner connectors. Okay, our 1x12 is going to go in and match up the other side of that. Okay, these are going to go on the end here, the flat parts facing the top. So now we need a 6-pitch metal shaft and 4 shaft collars. Pitch metal shaft and 4 shaft collars. So this metal shaft is going to go through right there. Okay, and then be 2 shaft collars on each side. So we're gonna push them through a little bit. Now these are going to stay a little bit loose for now. We'll get them worked into where they need to be in a little bit. So don't feel like you have to push them all the way to the inside, all the way to the middle, because they're going to be moved here in a little bit. So got that. That's good. 82, 2 more 1x1 connector pins, another right angle 2x3, and that is going to match up with the one that we've already got there on the opposite side. It's going to go like that. And on 83, we start to match up the side we've already put together. This is up here. I'll just hang on to that for now a little bit. So that's going to go right there in the top corner for the moment. And then this is going to connect to our connector pin on the gear. Okay. So you can kind of start to see what the mechanism is going to look like. So notice that I accidentally pushed the shaft through again. So be careful that that doesn't happen. Make sure that that stays all the way through. So see, now if we turn the gear, you can kind of see what's going to happen here. Okay. So we're just going to set this aside for the moment. Okay. So we need 4-pitch metal shaft, just like that. We need 2 more washers. A 2x4. One more 30-degree angle beam. The other 4x12 plate. 5 1x1 connector pins. Okay, so we've already built this, so we'll pull this back out. So this is going to have our shaft going through again. Again, we're going to make sure that it goes through flush on the side that has our shaft bushing and our connector pin. Okay, on the other side are the 2 washers. Okay. And then we're going to pull out those 1x4s with the shaft collar, or the 1x4s with the standoffs. I'll just kind of hang on to those right there for the moment. Set that down. So I don't know why they tell you to place those there right now. They're not going to stay, so don't worry about it. In step 88, when it tells you to put them on there, do that then. Okay, so our 2x4, we get 2 connector pins on that side, and our 30-degree angle beam goes like that. So that's going to look like the picture, more or less. And then we get our 3 that go in the middle of the 2x4, similar to how we did on the other 4x4 plate. And that is going to go just like that on there. Okay, so now we're up to step 88. So now we can put our shaft through the plate. So that's again going to be up. So 1. So you're at the 1 pitch, 2, 3, 4.5. Right there. Okay, and then we'll flip it over so you can see this a little bit better, but same thing as before. So our 1-bys with the standoffs come in and they'll hold this gearbox captive. So they're on the top. And we need these on the bottom just the same. So now it doesn't go anywhere. So make sure that the washers don't fall out as you're putting that in. That helps it stay halfway frictionless. And for this whole step, all we need is one little shaft collar and the whole mechanism that we built a minute ago. Okay, so that's gonna be there. So this is gonna connect onto the gear like before. So the thing that you're gonna wanna try and make sure happens is that the gears are in the same direction. The connector pins are in the same location in general. So go there, those go there. Okay, and then our standoff can hold that together. Okay. I lost this guy, so this is going to come in there. And that's where our shaft collar is going to go. Hold that in place. Okay, so now you can actually kind of see why these shaft collars were there in the first place. So the goal is to keep everything in place for this particular catapult. Okay. So again, we'll double check and make sure that those shafts are not poking through at all. We're good there. So we've got the beginnings of our catapult. So notice here it shows specifically this little eye. Pay attention to this. And they're talking about these shaft bushings. Make sure that they're lined up on the same side, because if they're all on the opposite sides, this mechanism isn't going to work. All right, so 5 more connector pins. 4 and 5. So the 4 go on the bottom just to match, so that it matches the other side. 2, 3, 4. And this one is going to match as well up here, which this one is on the 2 and the 4. So we'll go 2 and 4 right there. Okay, so now we're on this side. So we're going to grab one of these guys, and that is going to connect right in the middle of that. And then on the other side, we're going to do exactly the same thing. It's going to connect on the middle of that one. So it's kind of hard to make it match. Yeah, there we go. There, so you can see, kind of matches the picture now. All right, good to go there. 95. Uh-oh. Starting to look like a robot now. And we'll put our back. So these are going to go basically right in the middle of these two. So try to get those lined up exactly. Just pushing down right there. Okay, same thing on this side. Pop that down and the front down. So we have something that starting to look like a robot, don't we? Hold it up for you to see here. It's looking pretty good. Okay, one of the things that are a little bit tough to deal with though are these corner connectors here. They tend to wobble around quite a lot, so they're a little bit annoying to deal with. I think this one I'm going to pop around the other direction so that it matches the other one. So I don't know if the instructions are wrong or if I just did it wrong last time, but so here's what I did. I moved it so that the flat side is on the back to match the other one. So should be good there now. So this next step, you're about to run into a problem if you're trying to build this with only a super kit. So unfortunately, super kits only come with 4 30-degree angle beams. These instructions want you to use 6. So up until now, we've used all 4 of a super kit's 30-degree angle beams. So it's going to be up to you to try and figure out what you can do to get this to work correctly for you. Try out the 45-degree angle beams for this. This portion, all it's going to be doing is holding a bumper switch that's going to try and line up. It's going to try and line up on the bottom with this catapult mechanism so that you know when to turn it off when it's down low enough. So do what you can. If you have more 30-degree angle beams, definitely use them. But if you don't have them, don't panic. Just try out the 45s and see if you can make any small modifications to get it to work. All right, so we're going to set this aside for now. So this wants us to use 2 more 30-degree angle beams, even though you've already used all 4 of yours. If you're building with only a super kit, we've got a bumper switch, 4 1x1 connector pins, 2 wide 1x2 corner connectors, and 4 small chassis corner connectors. Okay, so with our 30-degree angle beams, we're gonna put our connector pins in. Put our connector pins in. And make sure that you're putting these in correctly. So flat side towards the angle beam, like so. Okay, that's one of them. And the other one we want to do on the other side. So that's going to be this side. And it's going to do the same thing. Okay, so it should look like that if you hold them together. Right. Okay, those are going to connect to the bottom of the bumper switch, like so. If you have more of these 2 wide 1x2 connector corner connectors, use those instead of using these small chassis corner connectors. These are a pain to get aligned. If you use the 1x2s, it goes so much smoother, but if you don't have more 1x2s, it's fine. These will work. You just have to make sure that you're lining things up correctly So these are going to go up towards, I'll do it like that. And like that. So the V is kind of in. And the same thing on the other side. And make sure the V is in. Like so. So you can see that they basically do the same job as the 1x2 corner connectors. But you may be out of these if you're only using a super kit as well. So do what you have to do. Okay, so we need another 2x16 and 2 more 2 wide 1x1 offset corner connectors. So they look like that. Okay, so this is going to go like so in the middle of the 2x16. So again, try and make sure that you get the holes lined up properly. And then these are going to go facing like with the flange on the inside here. So if you can kind of see how those are going in there. All right, so that's going to go on top of the front plate of the robot. So we will pull this back and try and prevent it from getting too much in the way. So I'm going to start on this outside here and put it into the large chassis corner connector and try and work my way across. So this part is a little tricky because you've got so many things you're trying to connect at once. The standoffs, you've got the offset 1x1 corner connectors with the connector pins. So you got kind of like 4 things here that you're connecting all at once, if you can see them. Okay, and then as you work your way across on the other side, you've got the same kind of situation happening. So you just have to make sure you get everything lined up exactly right before you start trying to force it in there. This is something that the kids may need a little bit of help with if they're lacking a little bit of the dexterity required to pop these in. And there's nothing wrong with helping them with, making sure they get pieces connected correctly. There's a big difference between building it for them, and helping them make sure that they're doing what they're trying to do. We want them to be successful, not to be extremely frustrated. Okay, so that's in there. So we're good there. So if you can kind of see this right here. So we want the arm to be down in this position when it hits this bumper switch so that it can send a signal to the program to turn off the motor. So that's what we're kind of going for here. So if you have to use other different angle beams for this, just make sure you can kind of get in the right position for this to work. Do your best. So one more large chassis corner connector and another 2x16. Okay, and the 2x16 is going to go on the back. So on the back, we've got all of these connectors that we're trying to get all lined up all at the same time. Again, do your best. I recommend starting on one side first, working your way across. So sometimes you gotta get kind of down and just work your way through. Just be patient with it. Don't try to force it. Okay. So that's on there. Good. And this large chassis corner connector is going to go on the left side here with corner connector pins going up. And that is going to connect. Basically, you find where this black connector pin is, right here on the standoff, and you just come right next to it as I pull things apart. Okay, so we've got our large chassis corner connector in. So 2 more 1x2 corner connectors. One 2x6, one 2 wide 1x2 offset corner connector, 6 1x1 connector pins, and a 2x10. Okay, so our 2x6 is out of the way for now. 2x6 gets the 1x2 connector pins through the end, and that is going to connect to the offset 1x2. So if you built this off the original instructions, you'll have noticed that this got updated. So in the parts list, it listed it as not offset, but in order for it to work, it had to be offset because this flange has to go over the edge. So that's a good fix. Okay, and then down on at the bottom of 102, you can see there's 2 more connector pins going on the end, and then this is just going to go on to the end of the 2x10. Okay, so then we need to bring the rest of the robot back, but first we're going to put these last 4 pins in. So they go in the 4 holes and the 1 holes. Okay, bring this back. And it's going to connect directly over this metal shaft right there. Yep, so that looks good. Turn it so you can see what we just did. Okay, so we need 1 more shaft collar, 2 more half pitch standoffs, and another 2x2. This one is actually a 2x2. So what's going to happen here is our shaft collar, let's face this the right direction here. So we're working back on the side we were working on before. So what's going to happen here is that we have a shaft collar that's going to go on this, but notice I just pushed it again. So that means I just pushed the shaft into the space in the middle, and we don't want that to happen. So make sure you're holding that on the inside when you push this shaft collar down so that it's still flush in the middle and it's not going to be in the way. Okay, so then you get 2 of these standoffs, go on the outside here. And then we use the 2x2 to hold that in place. So now that's not going to go anywhere. So that's all good to go now. Okay, we're going to work on this other side now. So we need 2 more 1x1 connector pins, 1 1x2 connector pin, and a 1x10. So this is going to need in the front here in the second hole, the 1x2 connector pin all the way through, and then one of the 1x1 connector pins on top and one of them on bottom. The one on bottom goes on the end, the one that's on top goes on the outside. Okay, and then this is going to go, we'll try and turn it so that it matches the picture best we can, but it's on my side over here, the side closest to me, and that's going to go right there. Okay, this is eventually going to turn into the bracket for the brain, and by eventually I mean right now. Okay, so 1 brain. And that is going to go on to those 2 connector pins that we're sticking up. So now we need two 1x1 connector pins and a T. So the T is going to get two connector pins in the top of the T, and then that is going to be put, move this into view, there we go, like this. That's going to go on top of the large chassis corner connector right here, and then into the top of the brain to hold it, help hold it in place. Okay, so the brain looks like that now. All right, so now we start to get into some of the tricky parts. Wiring. So the wiring for this robot is kind of tricky. There's a lot of really tight spaces to get into. Even smaller fingers have trouble with this, especially getting the connectors exactly in the right orientation to fit inside of the sockets. So my suggestion here is don't be afraid to disassemble part of the robot just to get these cables in, because that's about the only way you can really do it without really getting frustrated. So that's what we're going to do. And I'll show you how I do it here in a little bit. So the first thing we need is one 200mm cable and one 400mm cable. In your kits, the 200mm is the smallest one. It looks like this, right? So the way that I found to identify these is the 200mm, when they come in your kit, they come with one fold. Okay, so 200mm, one fold, you need one of those. So the 400mm is going to be twice as long as that, but it's not going to be two folds, it's going to be three folds. Okay, so 400mm, 200mm. So the 200mm you can see goes to the halfway mark here. Okay, so one fold for the 200mm. And we've got fold in half again, or three total folds in the 400mm. We are going from port 1 in the brain, just right here, down to the left drivetrain motor down here. So it's really hard to get a camera to show you exactly why this is so complicated. So I'm going to do my best to kind of show this a little bit here, but here's what I do. In order to best get this to work, I take off this bottom plate. So it's going to be a little bit annoying to put it back on, but it's far less annoying than trying to get the cable to snake through and into the right connectors. Okay, so we're just going to pop this off. Be careful that if you pull other parts off that you didn't mean to pull off, that you take note of where they go, where they came from. Okay, so put this guy back on, because I accidentally knocked off the large chassis corner connector. Okay, so we're good there. All right, so if you can see this here. So now we have kind of a straight shot into this, but you don't want to plug it in straight away. What you want to do is you want to try and feed it through that gap first. Okay, so we're going to push this cable through the gap that's right there as best we can. If you got to pull the motor down a little bit to get it through, that's fine. It has a little bit of room to give. Okay, once you get that through there, okay, then you can connect this cable to the motor. Okay, feed the rest of the cable through, and then on the top, you can connect it into port 1. Okay, so we're good with our first one. So we have our second one to go now, and the second one is going to go to the other motor on the other side, and that's further away to go, so that's why we need the 400mm cable. So same thing, we're going to feed this through first. So we push the cable through. Once we've got the cable through, we can connect this side to the motor. That. Okay. And now we can run this cable. You can route it however you want to route it, but really right there is more or less fine. We're plugging this one into port 3. There are a lot better cable management strategies for this. I recommend definitely playing with a few different ideas for how exactly you want to organize your cables. But with those set up, we can now put our bottom plate back on because we don't have any more that need to go through the bottom of the chassis. So we'll drop this back in here, try and make sure we line up all of the parts correctly. Put them in the right spots. Okay, and get our cross brace back in here. Good to go. Okay, so we got our first cables in there. So ports 1 and 3 are there. Okay, so now we're connecting the bumper switch in port 5 and the intake motor into port 2. Okay, so for this we need a 300 millimeter cable and another 400 millimeter cable. So if the 200 had 1 fold and the 400 had 3 folds, 300 only has 2 folds. So what this looks like, so your 300 millimeter wire, it's going to come like this, with both ends folded over on itself. Okay, and then the 400 millimeter is the one that's folded in half and then folded in half again. So we got a 300 and a 400. Okay. So the 400 we're going to save for going all the way to the intake motor because that has a little farther to go. So the bumper switch motor isn't that bad. And we mounted that backwards, so I'm going to fix that real quick. So by backwards, I mean I mounted it so that the port was on the front of the robot, and we want it the other way around so the port's on the back. So, but while you're here, you could just plug that in, pop that back on the bracket that we made, and then run the cable up to port 5. So again, please do better cable management than this. But for your first robot and for a first test, at least get it connected and working so that we can test things out. So, and then with our intake motor, so that goes into the intake motor, and don't be like me and pull the intake motor off because it's only connected with 2 connector pins in the middle of the motor, if you remember. And this is going to go into port 2. Ideally, you will route these down underneath everything. For now, whatever, it's fine. We're just trying to get it working. Okay, so we've got all of our motors wired up, ready to go. And move on to step 112. So we have a put this over here so we got a little space. So we have a shaft collar. We need 4 washers. 2, 4. Okay, we need 2 more 36 tooth gears. We need another 6-pitch metal shaft. That is all. Okay, so this one is a little bit tricky. It's not tricky to build, it's tricky to get exactly right. So I'm going to give you a little tip that I use because this shaft is exactly perfectly the right length. And that's great, except there's wiggle room. So there's room for it to slide out, and then that whole mechanism just doesn't work right if you don't get this exactly right. So we're going to start with, I need 2 shaft collars. So what you want to do on this is you want to work inside out. So first you put the shaft collars on the shaft. Okay. Shaft collars go on the shaft. Then the gears. So notice I put them on way farther than they need to be put on. Okay. And then 2 washers on each side. Okay, and we're going to take note kind of where this has to be because it's going to connect to the gears here. So you can see kind of what hole it goes in. So it's going to be that hole. But look, where it pokes out, that's way too far. So what we're going to do temporarily is we're going to take a connector pin and we're going to put it in that hole. So what this does is prevents you from going too far into that gap. So we're going to push the shaft up against that connector pin. We're going to then push the gear up against the edge. And we're going to move that shaft collar over to the edge. So now what you're left with is this just tiny little bit that's left over. That's exactly the right length that it needs to be. Because if you don't get this exactly right, what'll happen is this particular gear will fall out of the gearbox and fall out of alignment, and then your fling mechanism won't work, the catapult mechanism. So we want to make sure that this is aligned exactly right. Okay, so we're just going to set that in there for the moment. Slide this over a little bit. Come on down to the next part because we're starting to add more and more gears to this mechanism. So now we need our 8-pitch metal shaft, 2 more shaft collars, 4 more washers, similar to what we just did, but this time we're going to use the 12-tooth gears. And 4. Okay, we're going to build this kind of the same way that we built the other one, from the inside out. So shaft collars on first. And then our 12-tooth gears. Two washers per side. All right, so the trick we just did with this other set of gears isn't necessary with this particular one because it's an 8-length shaft. So we don't necessarily want it sticking out all that far. So we're gonna work it a little bit closed, but we have a lot of room to work with this particular shaft. So we're just gonna leave it kind of like that for now, and that'll be okay. Go on to this next side. So this will give us, or give our catapult some of the tension that it needs. So we need 2 1x2 corner connectors. Okay, and 1 2-pitch standoff. We got our 2 rubber bands and 1 smaller rubber band just for a little more oomph. That looks better. Okay, we're good there. So if you couldn't quite see what I was doing here, we got our 1x2 corner connectors. We got our 2-pitch standoff and our 2 rubber bands, but I added the 3rd smaller rubber band for just a tad more tension. Okay, and that's going to stretch down here, and that's going to be what gives our catapult mechanism the spring. Okay, so then we need our 6-pitch standoff. That's going to go in there. Okay, I also recommend not connecting these rubber bands to that quite yet until you have some of the other parts on, because it's just gonna, it could make a mess. Just wait just a second. Okay, so we're gonna go through and we're gonna put this part together for 116, 117, 118, and that's when you would want to put the rubber bands on. So again, we'll slide this a little bit out of the way. Get the parts we need. So we need 6 1x1 connector pins. 6. 2 1x2 connector pins. So we need a 2x6 and a 2x10. Okay, and we need a 1x2 offset corner connector. So this time we're going to put the short end in, so the 1x into our corner connector. We're going to push that through all the way on a 2x6 plate. Okay. 2 of the 1x1 connector pins are going to go in this end of the plate. So we've built this on the 2x6, and we have our 2x10 ready to go along with it. But the problem is, in a few steps you're going to find out that you need to add a capped plastic shaft, and it's going to stick out into a motor later. The problem is, to do it right, you actually need to have it inside, in between these two pieces. So where you're actually going to add this is going to be in here. So normally this would connect here, right? So we're going to go back 2 pitch on the half and stick that right there. So that's going to look like that. Okay. So what's going to happen is this is going to then stick out through the next piece. There's going to be a 12-tooth gear, and then it'll go into the motor on the other side. But if you don't do this here now, you're going to have a really hard time getting it in there later. So we're going to do this on step 117. I really think they should actually add this to step 117. We'll see how that goes in the coming months. But for now, I would just do it here, and we'll get this attached and move on. So the other place where this gets attached, we've already went ahead and put the 4 connector pins in here inside of for step 118. So all that's left now, we'll turn this up on its side here, is getting this all lined up. The tricky part here is making sure that all of the shafts line up in the right places for this part. I'm going to pull this down a little bit so you won't be able to see super well at the moment, but the tricky part is to make sure that this middle set of gears right here gets into the hole properly and stays tight the way that it's supposed to be. So we got our, all right, so things are good there. Things are good there. So our gearbox looks like it's doing what it's supposed to be doing. Okay. So some of our issues are that we've got bad cable management issues. So again, do a better job of cable management than I did. we'll see if it gets in the way here in a little bit, and we'll deal with it. If not, then great. Don't have to mess with it. Okay, so now that we've got that on the outside, we can move down here to step 119. So we've got 2 half pitch standoffs and a shaft collar, along with our 36 tooth gear. I'm just going to go ahead and add the 12 tooth gear onto this step as well. So our standoffs are going to go here. Our shaft collar, make sure again that you don't push this metal shaft too far through, because otherwise your catapult mechanism isn't going to work. You're going to have a bad time. Okay, and then our next standoff goes right next to our black plastic shaft. So, and our 36 tooth gear goes on that shaft, and our 12 tooth gear will go on the capped plastic black shaft that we just put on in step 117. Okay, so now we have a proper compound gear ratio. So this is going here from a 12 tooth gear to a 36 tooth gear. So that is a 1:3. And we've already determined that we have a 12 tooth to a 60 tooth, so a 1:5. So we take the 3 and the 5, we multiply them together to get 15. So this is a 1:15 compound gear reduction for torque. That'll help the robot be strong enough to high hang, well, low hang, but it should be able to support its own weight on the hanging bar from right here. Like that. Okay, so we'll move on. The one thing we haven't done yet is add this 2x10 on the outside. So we will go ahead and do that real quick. Okay, so that is in there now. So now you can see with that capped plastic shaft, it sticks out exactly enough for a motor to catch onto. Okay, and we already did the capped plastic shaft and the 12 tooth gear, so we can skip on ahead for that. Okay, one more or two more 1x1 connector pins. Another 2 wide 1x2 offset corner connector that is going to connect to this on the inside. Slide this over further this way. Do this here. Okay, and that's going to connect onto the back here. And then our 2x8 will keep all of this together. So we got a nice little sturdy mechanism there. Okay, 122. We need another 1x8 and another 1x1 connector pin. And this is going to connect here. And it's going to connect from, you can see these connector pins that we put in here down to this offset 1x1 connector. So we'll drop that in there, pop that in there. All right, so now we need 4 connector pins to get this motor attached. Again, we'll put the connector pins in the corners, or we'll drop them into the robot. And it's a little bit like a diamond, so we'll rotate a little bit so that we are making sure that we're putting that in the right spot. Try and get that in there correctly. Give it a little turn and we can hear the motor engage. So we're good there. See, now we're putting all of these wheels on. So now you wonder, why did you have me put the washers on in the first step? So yeah, don't do that in the first step, do it now. I actually prefer spacers for this, just to hold the wheels out a little bit. Given that these plastic shafts have some flex in them, I like to get them a little further away. So I'm going to use spacers. You can use washers if you want. You could use spacers. Doesn't really matter. The one kind of weird thing in this step, like, why wouldn't you just save the step numbers and put the shaft collars on right away? I mean, you've got it up like this. Might as well just do it, you know? So I put the shaft collars on now. But that's just me. You do you. See, I used up a whole page for that. I don't think that's necessary. So I need to do the other side with the other wheels. Well, or you could be smart and put your spacers on first. Get our shaft collars. And on there. Our other wheel. Shaft collar. Alright. So we got wheels. And a robot that'll drive a little bit. Got our shaft collars. So here are all the port assignments. The one thing that it doesn't tell you here is that, oh, by the way, this should be in port 4, the motor we just added. Go back through and make sure I didn't just completely space it. Yep, I did. It's right here. But they don't tell you what cable to use. So I would just use another 400 millimeter. It's one of the longer ones. And they want you to put that in port 4. So we'll stick that in port 4. And we're just going to route this kind of underneath everything. We'll go through the bottom and the back. Like that. And we'll come up in through there. And then we can plug that into the motor. All right. So we've just built Fling. What good's a robot if you don't try to drive it? Let's see what happens when we try and drive it. All right, so right now I'm going to put it on. I don't know how well that's going to show up, but I'm going to show you what happens if you try to drive this in driver control. Okay, so driver control, run. All right, so left stick, forward, reverse. Those are backwards, so that's not great. Left and right doesn't do anything. L up, L down, nothing. R up. So we get our So there's our catapult. And if you go a little bit further, it'll try to shoot. So we're getting stuck on a little bit of something, but maybe that's because we're going the wrong direction. So let's try it the other direction and see what happens here. I think maybe we're mostly just getting stuck on some of this cabling, so we really need to readjust the cabling. So I'm going to do that real quick, just to clean this up a little bit, and we'll be right back. And stop. Continue on. And it shoots. Okay. Right stick. F. E. Okay, so we got stuff that kind of sort of works, but it only drives the left side of the drivetrain. So now you see that driver control for this particular robot just won't work. That's because the motors are all plugged into the top ports on the brain. Driver control expects for certain motors to be plugged into certain ports and certain sensors to be plugged into certain ports. This build does not follow that at all. So the only one that's even in remotely the right place is port 1, which is driving the left motors. If you wanted to drive the right motors, you would need to have the right motors plugged into port 6. But fortunately, if we just dive into VEX code, we can actually program this really simply, really quickly, pretty easily. And fortunately, VEX has also given us a knowledge base article to show you exactly how to do that. So let's walk through that real quick. So if you're unfamiliar with how to get to the knowledge base, what you want to do is go to vexrobotics.com, click on Support and Help Knowledge Base. If you click this, and in the search, you just type Fling. This first link here is an introduction to Fling, the 2021-2022 VEX IQ HeroBot. So what you'll get when you go to that is this article, an introduction to Fling. And what this does is it goes through and explains the design strategies and what Fling is capable of doing and how it works and how it's expected to be used during a match. So here we've got, here it can score balls in the high goal, and here's how you do that, where you would have to be most likely. If you use different rubber bands, you're going to have to figure that out for yourself, where exactly your tension is going to lead you to the starting position. Putting balls in the low goal, that's pretty easy with the intake. Clearing balls from the corral, you can intake balls and then shoot them into the high goal. And then low hanging from the bar, that also works pretty well. It's just really slow, so you got to make sure you get there way ahead of time if you're planning on low hanging. It talks about the design features, how the intake is built, how it works. Notice in this one they've got a distance sensor here. This can perhaps be an opportunity for your kids to put this in and maybe sense when there's a ball loaded, ready to go. They talk about the intake and how its mechanism works. They talk a little bit about the firing system for the catapult. So notice a lot of these things that they have in this article are very similar to what your kids might want to put in their notebook. From design strategy, from the very beginnings, like this could be brainstorming. We want our robot to be able to toss balls into the high goal, and you just draw a simple diagram. We want to be able to push balls into the low goal. We want to be able to clear the corral. And notice everything here is based on how you score points in the game. And then they go into further detail about how each of these components is built to be able to solve that problem. They've got a little video here that talks about how exactly the linkage works for the catapult and how the balls get loaded. They talk about the compound gear ratio here that we talked about a little bit ago, and go through the math of how they got from a 3-to-1, 5-to-1 multiplied together to get a 15-to-1 compound gear reduction. And then they come in to what we're looking for. Tips and tricks for programming Fling with VEX Code IQ. So we're going to jump in and we're going to follow these directions and do basically what they're telling us here, and we're going to see how that works. So let's start from the top. You switch over. So here we've got VEX code. And the first thing that we need to do is we need to come here and add a device, and we've got a 2-motor drivetrain. Okay, so this is one where the drivetrain, the left motor is in 1, and I believe the right motor is in 3, and we are not using a gyroscope yet. Okay, so now we get to the track width, and the article has you change the track width from 173 to 267. So we'll change that to 267. So 267 millimeters. The wheelbase is the same. 76 millimeters, and the gear ratio is 1:1 for the drivetrain. And if you don't pay attention, if you remember from what we were doing before, our drivetrain was going backwards. So we want to hit this arrow so that we reverse the direction of the drivetrain. Okay, so now we've got a drivetrain. And you'll see over here that now we have drivetrain blocks that we can work with. But right now we're just doing our own version of driver control. So we're not going to worry too much about too many of the blocks quite yet. So next we need to add an intake motor. So we're going to add a motor, and the intake is on port 2. We're just going to name this intake. Okay, and then forward and reverse are fine. Note that you can change these, and that should be okay. And we need another motor for our catapult arm, which is in port 4. But our catapult has an up and a down, not so much a forward and reverse. So we'll rename those to up and down so that maybe that gets to be a little more useful. So now the only other thing that we have to add as a sensor or motor is our bumper switch, which is in port 5. So we'll just name that bumper. Sometimes it's nice to have the port number afterwards, but it's not really all that necessary. I like keeping them just nice and clean. So we got a drivetrain, an intake, a catapult, and a bumper. So the only other thing that we need to be able to drive this now is a controller. So we're going to add a controller. And when you have a drivetrain already set up, you can push, and other motors in fact, you can click areas on the controller to set some actions for the buttons. So if we click on this left joystick, you can see that our driver control is now in left arcade mode. So if you push the stick forward, the robot will drive forwards. If you push it back, it'll drive in reverse. But if you push left or right on the joystick, it'll turn to the left or right. So if we click it again, you'll get right arcade, where the right joystick handles the movement of the robot. If you click it again, you get split arcade, which is what my teams use most of the time, where the left joystick handles the forward and reverse and the right joystick handles left and right. This maps a little more cleanly onto normal remote control cars. So most of the time with remote control cars that kids get to play with, the left stick is forward and reverse and the right stick handles the steering of the wheels. So there's already a little bit of a predisposition being able to drive this way. In addition, I like this method a lot more because you can get a very clean forward and reverse without turns in it, especially if you add some gyroscope in the programming. If you use any of the other methods, you can accidentally turn while you're trying to move things around, and it's not as big of a deal, I think, in this game as it has been in the past. But in the past, there's a lot of times where you were trying to stack elements, or you're trying to get in and out of tight spaces without knocking things over, and you really needed that precise forward or reverse without the turn happening. So I like to keep it like this. If you click it one more time, you get the traditional tank controls where the left stick will handle the left wheels and the right stick will handle the right wheels. This is also known as skid steer. So some people really enjoy this. It is by a lot of people considered to be one of the most accurate ways to drive. It can take a lot of getting used to if you've never driven this way before. There's a lot of potential, but it is a pretty steep learning curve for some kids. So I found that this split arcade works out pretty well for most starting out, so we'll just start with that. And we'll use the right buttons for the intake. So there's a forward and reverse. So our R1 or R up will be forward and our R down will be reverse. And we'll put the catapult on the L buttons, where L up is up and L down is down. Okay. So with that, like that alone is enough to actually drive this. Like you don't even need to actually have any blocks in the code area. So let's load this program onto the robot and see how it works. First thing we're going to do before we do that is we're going to save this. And we'll just save it here as Fling. Okay, slot 1 is fine. Our brain is connected. So we'll hit download. Okay. We can hit run. So now if I go forward, reverse. Okay. Going left and right on the left joystick doesn't do anything. The turning is on the right joystick. Okay. Our intake. So up is forward. So this, in this case, you can decide what you want forward to mean. But in this case, it means it'll push the ball forward. Down, reverse, I have it pulling the balls into the robot. Okay, and then we have the catapult. Up and down is a little misleading with the catapult arm because you get a linear up and down motion based on a continuous rotation of the gears. So typically you won't do an up and down except for when you need to low hang. But for now, up means that it's going to rotate the big 60-tooth gears towards the rear, and then down means you're going to move them towards the front. So already we can drive this robot. Like, we can make this work. But that's not necessarily the best thing to do, because we can get a lot more power out of some of the shortcuts that we can do with the programming, because we have this little bumper switch down here. And we haven't done anything with that yet. So let's jump in and let's do something with that one. So if you go down a little bit further on here in this article, you'll see they start having some code that you can try out. So when you're using the catapult arm motor with the controller, we want to set the stopping to hold. So the reason that you might want to do this is because if you're trying to hang and the stopping isn't set to hold, it's going to maybe pull itself up, and then it's going to just let itself down as soon as you stop trying to pull it up. So if we come in here to the motor section and we look at the stopping, we can come over here to our help section, click the stopping, set intake stopping. We can change the motor to catapult, so set catapult stopping. We want to set this to hold. But there's this whole help section that you can see over here that'll tell you all about it. What brake does, what coast does, what hold does, and when and how long this block will take effect. So right now we want to, as soon as the program starts, we want to set our catapult stopping to hold. And then we're just going to continue down on the article. So the next thing it has for us is, hey, let's change our L down and L up to mean something else. Okay, so what would make sense for L down? So if we're thinking about a catapult, L down should be like load. So if we're going to load the catapult, what do we need it to do? So basically, with a load situation, what we want to happen is we want this to come down and then stop when it's at the bottom and be ready to launch. So the way that we can do this is we can tell the motor to turn, and it's going to continue turning until this bumper switch is pressed. Because once this bumper switch is pressed, we know that the catapult arm is all the way down and in the ready position. So the first thing that we need to do is come back into our controller, and let's just unset L just to make sure that nothing is getting in the way. So then we come back over here and we go to events. So what we want is when we press a controller button. So when a controller button, let's go with L down because we're doing a load, it's pressed, we want the motor to spin. So we're going to spin catapult down. But we want to keep going until something happens. So we're going to wait until, and in our sensing, we want to wait until the bumper is pressed. So this should have the motor spin and pull the catapult down until that bumper button gets pushed down. If you just leave it like this, what's going to happen is it's just going to keep spinning. So we've told it to spin, but we've never told it to stop. So we need to stop the catapult. So now anytime we press L down, it's going to spin the catapult down until the bumper's pressed, and then it'll stop. Now the next thing we want to do is launch, right? So we need another event, and we'll do when the controller L up is pressed. So this is going to look very, very similar. Okay. So what we can do, instead of pulling this out, we're going to right click on this controller block and duplicate. So now we don't want another L down. We want L up. When L up is pressed, we're going to just keep spinning down, because the way that this mechanism works, you just continue to spin the motor in one direction. But the way that the linkage works, it'll just keep pulling the arm down and letting it go, and then pull it down and let it go, and pull it down and let it go. So we're just going to keep spinning down. But now we don't want to wait until the bumper is pressed. We want to wait until it's not pressed. So we're going to pull this not block in, put the bumper pressed in that, and put that in the wait until, and then we'll stop. Seems fine. So the arm will go up however far that it goes up, and you're good. So let's download that, and we'll run this and see how this works. Okay, so we'll press L down. So it's going to continue rotating, rotating, rotating. Now this is going to keep going and going and going. Okay, the bumper's pressed and it stopped. Okay, if we press down again, nothing really happens because the bumper's already pressed. Okay, so now if we press L up because we want to shoot, that was a little delayed, but I may have gotten hung up on something. But it shot, so we press L down again. So you notice how this takes a really, really long time to reload. Okay, and then we'll hold L up. And it shoots. So now we have a programmed controller with a robot that is ready to go. You know, if you have the belt to use for this, definitely use that. That is far better than using a rubber band. If you have a chain and sprocket kit, convert this. You'll have to make it a little bit wider, but that is far superior to this situation. But in a nutshell, that's Fling. So there were definitely some tricky parts to this build. There were definitely some places where the instruction manual is still a little bit lacking and still has a few errors here and there, but nothing we couldn't overcome. Nothing too completely terrible. There are definitely some gotchas here and there. There are definitely some places where if you didn't have pre-knowledge of what was coming, you might have to go back and retrace your steps a little bit. So what I hope you've gotten out of this video, if you've been following along, is that I hope you now have a functional Fling that you can go and use. If nothing else, then you have the knowledge to go back and help somebody else who's building Fling. If you're a coach, you have a little more knowledge about how to build Fling so that you can better answer the questions of your kids when they're starting to build Fling. I know for us, we're going to be having a summer camp coming up soon, and we're having all of our kids build Fling. If you remember at the very beginning, we built several different pieces and then didn't actually combine things together until later on in the build. So there's a lot of potential for giving kids different sets of instructions to build so everybody can be building all at once. But all in all, Fling is a pretty fantastic starting point. It's not an amazing robot by any stretch, but it'll get your kids excited about what they could build for this game. This unlocks a lot of potential. It teaches a new mechanism that they've probably never dealt with before with this linkage inside of the catapult. This is the first time they've ever had any sort of intake mechanism on one of their HeroBots. So now the kids are learning about intakes, they're learning about converting rotational motion into linear motion. There's a lot of fantastic things that I love about this build, but it is a little bit on the more difficult side compared to some of the previous HeroBots. If your kids are having a lot of trouble with this, there's definitely some other things that you could do. There's some other robots that you could build, but you'll definitely get a lot out of trying to build this at the very least. I think a lot of people, if you take the time and go through the process of getting this built, especially with some of the difficult portions that I've pointed out in this build process, if you can get past those, there'll be a lot of great things that you learn along the way. A lot of interesting build tips and tricks, a lot of interesting uses of parts that we don't normally use all that often. I love the fact that they used washers and spacers a lot more in this build. They're very underutilized in a lot of programs. I love the fact that they're really, with this build, encouraging people to get in there and program their driver control instead of relying on the built-in driver control. The downside to this is there's going to be teams out there that just don't know, and they're going to be very confused about why driver control isn't working with this robot. So I encourage you to get out there and encourage those teams to looking a little deeper into what is available. With this knowledge base article VEX gave us, they basically give you the program. You just have to follow through, follow the steps, and build the program, and it gets you your first taste of what it would be like to program a VEX robot if you've never done so before. If you are one of those teams that's been constantly relying on driver control because you were just intimidated by programming, I hope that what I've shown you today is that it can be really simple. And you don't have to be scared of programming the robot. And there's a lot of neat things you can do once you unlock that power, once you unlock that potential inside yourself. Thank you for joining me in this build, and I hope you had a great time, and I hope you have a fully functional Fling that you can use as a platform to jump off and build something even better, starting with maybe some simple modifications to Fling and moving on into something even more complicated, maybe even a record-shattering robot that no one will see coming at Worlds. I can't wait to see what you come up with. Good luck. We'll see you out there.